So last time we discussed the basics of object-oriented programming. We discussed that object-oriented programming is we think the system as a set of objects that communicate and collaborate to achieve the common objectives. And to represent all the similar objects, we have one class. To represent all the accounts, account class. To represent all the customers, a customer class. To represent orders, order class, and so on. So then we discussed that class models or represents similar objects or same objects. And also class can act like a blueprint or factory to create objects. And what are the two things we are interested? Attributes and behaviors of each and every object for each and every class. And then we discussed that these attributes can be instance variables or it can map into a class variable. So if every object gets its value like balance of the account, price of an item, so those are instance variables. But if it is a common value for all the objects of that type, it's a class variable, like interest rate of account. Okay. So then instance methods are methods that refer to at least one instance variable. If your method refer, that is read or change at least one instance variable, it's an instance method. You can't use static keyword. But if your method does not refer to any of the instance variable, it may refer to class variables, then it's a class method, static method. And finally, we discuss what is meant by constructor. Constructor is like a method, instance method, but it is automatically called at object creation time, and afterwards you can't call it. That's it. So that's it what we discussed in last class. Okay. In a sense. Okay. And of course, we discuss how to create object using new keywords. Okay. So the difference between instance method and class method, and what kind of things your class method can access. Basically, class method can call other class methods. Class method can access class variables. But class method cannot access any of the instance method. No, class method cannot call instance methods. But instance method have access to instance variables, class variables, instance can call other instance method and can call other class methods. Constructor have access to the instance variable, class variables, and it can call instance methods. But no one can call class in constructor. It's automatically called at object creation. So that's it. So that's it. Okay. Right. So now we move on to few more concepts, basics. That is abstraction, encapsulation, data hiding, association, inheritance, and polymorphism. Once these 5 concepts are discussed, object orientation is done. Okay. Right. So our next concept is abstraction. Abstraction. Now, if you have any question about what we have done so far, any question, right? So you can ask. I will explain it. But only if you ask. Okay. Only if you ask. Right. Any questions? No question? Right. So if you don't have questions, I don't have any issues as well, right? So let's move on to the next concept, abstraction. So abstraction is a very basic concept, okay? But very important concept as well. So abstraction means when you model, design, develop classes, we model minimal required features. Therefore, we develop also the minimal required features. So that is called abstraction. Okay. So model only minimum essential details of an object. That is not something only for object-oriented software development. That is general principle we use as engineers. It's a general principle in engineering. So remember, engineering is all about building complex systems, cost effective, right? Durable manner. So when we do that, one of the principles is we develop or build the essential things. Get rid of all the bullshit, unnecessary things. Because when you get out of all the unnecessary things and concentrate on the essential, uh, the complexity is also less because you don't think about the unnecessary details. And cost is less. We can do it faster and so on. And it is part of the Western philosophy as well. So Western philosophy means the way Western people think. Of course, we learn Western engineering, Western medicine, Western education, whether you like it or not. So part of Western thinking is abstraction. Do only minimum essential. Get rid of all unnecessary things. Okay, right? That's it. So that's it about abstraction. So when you model, say, account class, so we only model essential things like account number, balance, interest rate, deposit, withdraw, add interest. So then life is so beautiful, right? Life is so beautiful. Life is so simple because we only concentrate on essential. So then we can start something and finish something. Okay, right. So another aspect of abstraction is hide the implementation details. So this is a little bit more technical as way of looking at it. So when you create a class, you expose your attributes and behaviors. Of course, attributes are also we restrict later on uh, as method signatures rather than implementation. So someone calling a method must not understand or know exact implementation. It must know only what to do, what kind of data I'm supposed to send, what kind of results I will be getting. That is good enough. Okay, so that is called abstraction. Abstraction. For example, this is the abstract view of bank account class. So this contains all the things that we're interested. What are the attributes? What are the methods? Okay. So this view is enough for the external people. But when you implement deposit method, withdraw method, you need more details. But that is not required for other classes to call this, work with this. Okay, that is the idea. So the advantage is can focus on the essential, simplicity. We can do things faster, build things faster. Okay. Abstraction is an engineering idea. We right science. It's a philosophical idea. Actually, the better answer is it's a way of thinking. It's a philosophy. So some people want to make things complicated. Some people want to make things simple. Right? Some people want to be simple. Some people want to be complicated. So it's a philosophy. Philosophy means where how do you look at life and how do you live? Okay. Right. So abstraction is really important for engineering. But if you are something like artistic mindset, so don't confuse abstraction. Sometimes you may end up with become a bad artist, bad novelist, bad poet, bad dancer, singer. So that is a different area. That is a different area. So there is a difference between the art people and science people. Right? So some people think that it's just they learn set of subjects. Science people, technology people learn. No, that is not the case. So the way we think is also different. Our philosophy is different from their philosophy. Our philosophy is logical thinking, engineering, building things, make things simpler. Okay, right. So that is abstraction. So abstraction means what? When you develop something, design something, concentrate on minimal essential. Don't make your life complicated or don't make your system complicated by adding unnecessary things. Unnecessary things. So that is why some people find engineering, computer science difficult because their mindset is art. ඒගොල්ලෝ ජීවත් වෙන්නේ සෞන්දර්යය ඇතුලේ, ආර්ට් ඇතුලේ. කරන්න හදනවා IT. එහෙම කරන්න බෑ. කරන්න බෑ. මෙතනට ආවට පස්සේ හිතන්න ඕන ඉංජිනේරින් මයින්ඩ්සෙට් එක. ඉංජිනේර කෙනෙක්ගේ මයින්ඩ්සෙට් එක. ඩොක්ටර් කෙනෙක්ගේ මයින්ඩ්සෙට් එක. For example, say you want to be a surgeon. Right? So when you are doing a surgery, you need to cut. Okay? Cut and open. So you must cut and open the minimum essential. Minimum essential. So that is scientific mindset, engineering mindset. But say you are a, how do you call that, dressmaker. Then of course that is different. මෙහෙන් රැලි දානවා, ආර්චි දානවා, බෝරිච්චි දානවා, විශේෂයෙන් ඒවා කෙනෙක්ට හඳුන්වක්කදී. ඒතකොට එයාට පුළුවන් එහෙම කරන්න. ඒතකොට එයාට ඔපරේෂන් එකක් කරන්න දුන්නොත් එමෙතන කදින මැස්මක් දායි නේ. මේක වැඩි ලස්සනයි කියලා. එහෙම කරන්න බෑ. So engineering scientific mindset is different from other mindsets. Okay. Right. Next concept is encapsulation. Right. Encapsulation means encapsulation. You know what is capsule? N means you make it a verb, like encircle, vatakarno. Encapsulation, that means put it into a capsule, put it into a structure. Okay. So when you design classes, class itself is a structure. That is why we write something like class, account, something like this. So this is my structure. So inside that you have the account related functionalities. Inside payment class, you have payment related functionalities. So that is encapsulation. Encapsulate different functionalities into different classes. So that now we can think better, design better, because now we have different concepts isolated to different classes. Okay, different classes. Encapsulation. So that is again part of thinking, philosophy. If you want to be IT professional, think like that. Isolate things and then see how these are interrelated. But make it isolated. Okay, make it isolated. So if someone asks, can you give me example of using encapsulation? When you write a class, it's encapsulation. So class account related functionalities are encapsulated to account class. Order related functionalities are encapsulated to order class and so on. So we need a bit of structures, right? It's like we use cups when we drink. So when you use a cup, it's easier to drink. But if you take dog or something, other animal, they don't know how to use a cup. So they sometimes really mess it when they drink. But we can drink in a very disciplined manner because we can encapsulate it into a cup. Okay. Right. So there's a special case of encapsulation. Now we can take these as a separate concepts also. So when you encapsulate, of course, we can hide complexity, better modularity, better control, better maintainability, because different functionalities are now encapsulated into different classes. එහෙම නැත්නම් මේක නිකන් එකපාර නිකන් හොද්දක් වගේ ඔක්කොම එකට දාපුවා. So then it's unnecessarily complicated. Right. So the next concept is data hiding. If you want, you can consider data hiding as a special case of encapsulation or strict form of encapsulation, or you can consider data hiding as separate concept, which is somewhat related to encapsulation. Data hiding. What is mean by data hiding? So the word itself says, what is the literal meaning of data hiding? Hide your data. Hide the data of a class. So remember class has, so let me open the account class. We developed last time. Right. So you can see these are data. These are data, interest rate, account number, balance. So these are instance variable, these are class variable. Now data hiding means hide your data from outside objects. So, okay. Now these are not data hidden. For example, in the account test class, you can see that this other class has set the account number. That is bad. Even I can set the balance, right? For example, I can say here A1 dot balance equal say 1 million. This is pretty bad thing to do, but this is possible because data is not hidden. Now, can you go to the bank and say, change my account balance to 1 million? They will say, no way. That is against our policies, procedures. So if you want to make it 1 million, deposit money, show the deposit behavior. So then of course your account balance will be changed to 1 million. If your currently it is 0.1 million, deposit 0.9 million, then of course balance will be 1 million. But we can't go and change it to 1 million. That is not how the bank operate. Okay, so now you can see my data is not hidden. Data hiding is not implemented in my account class. So data hiding principle means hide your data. Hide your data. Still, others can influence your data through behaviors. Through behaviors. Okay. So how do you do that? Very easy. Make your data, that is instance variable and class variable, private. Private. Now, external classes cannot access your data, even not even read data. Okay. You can even make your class variable also private. Private means it is only accessible to your members. For example, still I can access the balance can be accessed by your deposit method, withdraw method. Private things you can, if there's something private for me, I have the access to that. Maybe others can't access. So private things, your instance method, class methods can access. Constructor can access, but other classes from other classes they can't access. Now I made balance private or data hidden now. Account number private. Now you can't go and change the account number. You can see now it's red. Now you can't go and change the balance because that violate data hiding. That is why we make those private. So now you can't do like this. Okay. So what you can do now? Okay, let's keep that. Still, you want to change the account number. So you can change your attributes, change or read your attributes only through behaviors. That is what data hiding. Data hiding means what? Make your data private and let those data access only through behaviors. That is called data hiding. Okay, data hiding. Okay. Right. So now I have made those private, but I have not given a method to access your account number. So how can we set the account number? So then you can do it using maybe a method. Already we can access the balance using withdraw method, deposit method. Right? Because when you deposit something, your balance is increased. But what about my account number now? So you can write some methods. Of course, this is not at all allowed. Okay. So this is how you access your private data, deposit method, withdraw method, and so on. But in some cases, We like to access these data using specific methods. We call them getters and setters. If you have your getters and setters for your private variables, then we say that that data hidden class is the Java Bean class. Java Bean class. So if it is a Java Bean class for your private variables, you must have getters and setters. Getters and setters are methods with specific format. For example, if you want to set the account number, you write something called set account number. Set account number. Right? Void set, then the attribute name, but start with capital. Account number. So there you can send the account number string. So then what we can do is I can set this parameter to this particular area, ACCT now. This must be string. Okay. Now this is the setter method. Now I can generate the getter method. So if you follow this set get convention, then we say you are right, you have make it a Java B. But if you don't follow, still it is data hidden, but it is not a Java B. Okay, say get account number. Then of course you need to return string because account number is a string. No need of parameter. And now you can return the account number. So now my account class follows Java Bean convention because I have setters and getters. Okay. So how do you understand? Encapsulation is put it into structures when you model. Data hiding means make your data private and expose them through behaviors only. Java Bean means a special type of data hiding class where we follow the getter setter method standard to access and change values of private data for each and every private data. Right. So this is how you write getters and setters for a particular variable. Okay. So if it is something like some other type, double, then here it is double, here it is double. Okay. So Java Bean is well encapsulated data hidden class that follow getter setter coding convention. But if you do not follow getter setter coding convention, still it's data hidden if your data is private and exposed to different methods. Right. So how many concepts we have discussed so far? Today, abstraction, encapsulation, data hiding, and special case of data hiding called Java Bean class. Any questions? Any questions you're having? So no one asks why do you want to hide data because you don't have that culture. You are not from that culture, right? So if you are a critical thinker, you must ask why do you want to hide data? First of all, you must have asked why do you want to make encapsulate? Of course, for that I gave you a partial answer. So why do you want to make your data hide? Simple answer is that is how in general in business things happen. So we must respect those business rules. For example, you can't go to the bank and say change my balance to 1 million. They will say no, that is against our policies, procedures. So if you want to make it 1 million, deposit relevant amount of money, then it will become 1. So therefore, in reality, in real world, we hide data very often. So therefore, in programming also we want to do it. Otherwise, our application may violate business rules. Okay, right. Again, if you have any questions, you can ask. And also when we access data through behaviors, we have we can apply some validations so that the garbage values are not assigned, and better access control like private, public, protected. And also we have better flexibility to change the data structure, internal structure. Okay. So this is an example of data hiding, and not only data hiding, yeah, this is pretty much data hiding only. Your variables are now private. You can access those private variables only through the behaviors. So this is not a Java bean, but definitely data hidden. All your data are private. Okay. Yeah, object expose only relevant data. Ideally, object should not expose data, but rarely we need to expose for practical reasons. But ideally, object must not expose data to other objects. Rather, you expose only behaviors or methods, and those methods can change the data. So that is what is meant by data hiding, encapsulation. So encapsulate data hiding is a special case of encapsulation. If you follow Java Bean standard, so this is how you get the setter and getter method. Get text, set text. But if the return type is Boolean, even you can say is, okay, is rather than get. Or you can just use get for Boolean as well. So this is sort of a complete Java bean with multiple attributes. Each attribute has a getter and setter. So it's not a must to write your getters and setters. Okay, it's not a must. But depending on your requirement, you can write getter and setter. So then it is Java bean. Okay, right. So association, inheritance, and polymorphism we will look in next few topics. So now we have completed our discussion on object-oriented basics. What is class? What is object? What is attribute? What is method? What are instance variables? What are class variables? What are instance methods? What are class methods? Then what is abstraction? What is data hiding? Right. So in next note, we will look at few more data object-oriented concepts. Okay. Right. So our next subtopic is association or association relationship between classes. Okay. Is that object communicate only with behaviors? Yes, when we say communicate or messaging, it is basically calling a behavior. Other objects are not supposed to access some other objects' attributes or variables. That is bad practice, bad coding. So other objects must be able to call behaviors, not directly change the attribute values or read the attribute values because it's dangerous, security wise, business rules wise, and so on. There's another question. Can a Java bean have other methods? Yes, it can. That is a very good question, actually. Java bean class, other than getters and setters, it can have any other method as well. But it must have the getters and setters, where your attributes are private. Okay. Right. So now we move on to our next concept, association. Association. So remember, I mentioned you that when we develop object-oriented software, at runtime, set of objects communicate and collaborate with each other. So that means this object can send a message to this object can send message to that object, and so on. So then there's a question, which object can message which objects, which other object? For example, can this object message this object and vice versa? Or can one object communicate or message any other object? Or is it just one object or is it many objects? How do you decide which object a particular object can communicate? So that is what we discuss in association. So what is mean by association? What is the literal meaning of association? Association. Okay. So let's ask what is the literal meaning of association? A group of people organized for a joint purpose. සංගමයක් කියලා කියන්නේ ආශ්‍රයයක් කියලා කියන්නේ associate කරනවා කියන ආශ්‍රය කරනවා සංගමයක්. Group of people organized for a joint purpose, that is noun, right? Connection or cooperative link between people or organization. Collaborate, cooperate between people, we call it association. Association. So then what is the meaning of association relationship? The association relationship means if class A is associated with class B, that means class A and class B can collaborate, communicate. Simple as that. So that means not every class can collaborate with each other, or not every object can collaborate with each other. Right? Some classes, so some objects can collaborate with some other object. For example, say we have X object, Y object, Z object. So different Z objects are different X objects are there. Maybe X can collaborate with Y, but X may not be able to. Sometimes X cannot collaborate with Z. X can collaborate with Y, but not with Z. So that means X and Y are associated, or there's an association relationship between X class and Y class, but there's no association relationship between X class and Z class. If there's an association relationship between X class and Y class, then objects of X class can communicate with objects of Y class, or objects of X class can message objects of Y class. Or in other words, objects of X class can call behaviors of objects of Y class. But if there's no such association, you can't do that. Right? X object can't call behaviors of Y objects. So that is what association relationship is. Have you got it or still confused? Why? So there's a question. Can Java Bean have other methods other than getters and setters? Then why do we call it Java Beans? So if you write your code following a convention, so we give it a name. Right? If you follow a particular convention, that is when your attribute is X, the two methods are getX, setX. Then to identify that this is a class that follow that convention, we just give it a name saying Java Beans. If you do not follow that, we don't give it that name. Okay. So that is the simple answer for that. Then maybe your question is, while you following the convention, if you have additional methods, yes, that is fine. So while you follow the convention, you can have additional methods. Those are not getters and setters. Those are additional methods. But you follow the convention. So then still it's a Java bean. That is called association relationship. If there's association relationship between two classes, then object of that class can call behaviors of the other class. It's something like this, right? Say this is you, your family. This is your left side neighborhood, neighbors. Right? This is your right side neighbors. Assume that you have association with these guys, but you don't have any association with these guys. ඒ කියන්නේ මේගොල්ලොත් එක්ක ආශ්‍රය කරනවා මේගොල්ලොත් එක්ක ආශ්‍රය කරන්නේ නැහැ. ඒක ඇසෝසියේෂන් එකක් කියන්නේ ඒක. ඇසෝසියේට් කියන්නේ ආශ්‍රය කරනවා. You have association with these guys, but you don't have any association with these guys. So when you have association with this family, now you can get some help from them. You can talk to them because you have association. Maybe they also can get help from you, but you don't have any association with this family. That means you usually you don't call behaviors of them. They also don't call behaviors of you. Neither. Because ඔයගොල්ලෝ අතර ආශ්‍රයයක් නැහැ. So therefore, if this is A, this is B, this is C as classes, this is your A class. Maybe A class has association with a B class. That means A and B have association relationship, but there's no such association with C. C is isolated. Maybe C is have association with D. C and D families. And then there's association between C and D. But there's no association between C and A. That means C cannot call behaviors A objects. A objects cannot call behaviors of C objects. If there's association relationship only, there can be message passing or method calling. And again, it has a direction, unidirection, bidirection. If it is bidirection between A and B classes, then A object can call behaviors of B object, B object can call behaviors of A object. Sometimes it can be one unidirectional, like this. That means A can call behaviors of B, but B can't call behaviors of A. That is unidirectional association. So if there's association, only possibility of message passing is there, and again it can be one unidirectional or bidirectional. Therefore, association relationship determine which objects can pass messages to which other objects. If there's no association, for example, if there's no association between A class and C class, A object cannot pass message to C object and call behaviors. This is not allowed. Okay. Right. Now let's look at, now I hope you got the idea, concept. So now let's see how to implement it, code it. Say this is my class A. Okay. If A is associated with B, say my A class is associated with B class. Something like this, say unidirectional. So then your A class has instance variable of B class. That is, if A is associated with one A object is associated with one B object. So every A object is associated with only one B object. So then this is the class structure of class A. Your class A has instance variable. Usually instance variables are something like account number, balance. Those are primitive data types, right? Double, string. But this time you have instance variable which is of type B, class B. And this instance variable is available to all the methods, instance method, class methods. No, not class method, instance methods. So therefore, your methods, A methods can call B methods because this object is available. Okay. And if it is one-to-many relationship, one-to-many or one-to-n, so then A has not one object of B, maybe array of B objects or list of B objects. So one A object is associated with, in this case, 4 B objects. So one A object is can be associated with maybe 4 B objects or any number of B objects. So that is one-to-many association. This is one-to-one association. So if you don't understand these things, you will never ever do object-oriented programming. Okay. Because there are concepts like object relational mapping. In databases, one-to-many relationships are there. So this is sort of a unidirectional. If it is bidirectional, similarly, B class must also have A object. So then bidirectional. Okay. So this is unidirectional. Who objects can call behaviors of bar objects? Okay. So you have to consider direction, multiplicity. Is it one object associated with one object or many objects? Is it one way? Is it A to B only or B to A only? Or both A to B and B to A? So those are the things that you must consider when you design, when you model association relationship between classes. So this is unidirectional association, one-to-one association. One foo object is associated with one bar object. But bar objects are not associated with foo objects because this is unidirectional. Okay. ඒ කියන්නේ x පවුල y පවුලට එක එකව කියලා කරව ගන්න. හැබැයි y පවුල කවදාවත් x පවුලට මුකුත් කියන්නේ නැහැ. ඒගොල්ලෝ කියන දේක් කරලා දෙනවා. හැබැයි අරගොල්ලන්ට මුකුත් කියන්නවත් අර කරලා දෙන්න මේක කරලා දෙන්න කියලා කියන්නේ නැහැ ඒගොල්ලෝ. It's a unidirectional. So then someone will ask, can we have that kind of relationship? Of course, in reality, maybe not. But in object-oriented coding, plenty of those associations are there. Unidirectional associations are there. Or can be there, depending on your domain requirements. So foo object can call behaviors of bar object because it's unidirectional one-to-one association. So this is how message passing happens. So your foo object can call behavior of a bar object. Of course, this is my test class creating the foo object's behavior. That is my test class. Test class create object of foo object and call do foo behavior. Then maybe do foo behavior can call do bar behavior of a bar object because your foo class has an instance variable of bar class, bar object. So when you test class call the foo do foo behavior of the foo object, as part of doing that, foo object call do bar behavior of a bar object. So now you can see objects are collaborating. So this object get help from this object to do something. That is how object-oriented software is developed. There's no other way. Whether you like it or not, one day you must understand this. Then you can develop object-oriented software. You don't understand this, ever you say, forever you don't understand this, forever you can't do object-oriented software development, programming. Simple as that. So therefore, ask any question and clarify this. And more than that, start doing some coding. Start doing some coding. So I gave you about 4-5 coding exercises last week. No one gave me the answers. No one. No one sent me the answers. They are your answers. I don't know why. That you think. What kind of objectives you are having by studying BIT? Whether you want to be IT professional or you want to do something else with your degree certificate. I don't know. Malwala kannada bell ellang innadi කියලා. Right. So this is a practical sort of. This is not a very practical code, but just to demonstrate this phenomena. Okay. So let's code it. So you must code the practical scenarios. Okay. The practical මොනාර දුන්නට ඒකට උත්තර exercise එකක් දුන්නට කරන්නේ නැහැ. මොකද්ද ඒකට ඇති වැඩේ? Right. So let's create a. Right. So now remember the account numbers are. Let's fix this one and get back. Okay. Make it our. Now we have the set account number, get account number. So therefore, let's call the set account number. Make it demo. So now I need to call set account number because now it is data hidden. But now my account class is data hidden, well encapsulated. So here you must call get account number. Now you only call behaviors. Message passing means call behaviors. It's bad thing to access attributes like this from other classes. Very bad thing. Now we fix those issues. Make it more professional code. And interest rate is a class variable. For that also we have made private. It's better to have getters and setters. Make it Java. Even your IntelliJ can generate the getters and setters. Okay. For example, here you can right click and say generate getters and setters. Generate, you can see, right? I just right click somewhere in the code. Generate, because these are normal things we do as software developers. Generate. I would say getter and setter. Then it will ask for which one you want getter and setter. Anyway, already we have getter and setter for account number. I will say interest rate, which is a static variable. That is fine. So it will generate get interest rate and set interest rate. Now I can read the interest rate. Still I can set the interest rate, but this time by methods because my data is hidden. Data is hidden. Okay. So now let's call the get interest rate and make it. This is set interest rate because we want to set it. So what else we need to change? Maybe balance is also, yes, balance you can't do like that. Here also we need to call get interest rate. Get, because now we generate, just now we generate the interest rate. We generated that. And balance, we make it private, but no getters and setters, right? No getters and setters. So let's generate the getters and setters also. I will keep somewhere here and say generate getter and setter for balance. Now I can call the get balance. Now I can make my code again working, but now it's well encapsulated, data hidden. Now I can run this. And I will get the exact same output. I just use some more object-oriented concepts. Okay. Same output. Right, so now let's get back to our coding. Say I have a class called say foo. I have a class called bar. So usually foo bar is something like X5 for software developers. Okay. No specific PD, just to demonstrate theory part. Right. So now I want to have association between foo and bar. That is, foo is associated with bar, but bar is not associated with foo. And it is one-to-one. So then what I'm supposed to do? Create a foo object here. Sorry, bar object here as instance variable. Bar, let's say B equal new bar. So that is how we create association between foo class and bar class, unidirectional. Okay, say now my foo class has a method, instance method. Say void, let's call it do foo. S out, do foo. Now similarly, let's assume my bar class has method called do bar. So there I don't create a foo object because I want to make it unidirectional. Let's call it do bar. Do bar. Now as part of do foo behavior of the foo object, it can now when other class create a foo object and call the do foo behavior or message the do foo behavior. Now do foo behavior can call do bar behavior of a bar object. එතකොට foo object එකක් හැදෙනකොට යාට සහයට bar object එකකුත් හැදෙනවා memory එකේ. Because this variable is available to the do p dot do bar. So that is what association is. That is what message passing is. Right. So now let's create a class called foo test. Public static void main. I just create a foo object. Now I call the do foo. So when do foo object is created in the memory, bar object is also created. Because whenever foo object is created, bar object is created. And when I call do foo behavior, the foo object send a message to the B object calling do bar behavior. That is what message passing. Okay. Right. So now let's run it. Foo test. So I call the do foo behavior. Therefore, do foo output is there because do foo behavior is called. But then in this do foo behavior, do bar behavior is called of the associated B object. That is how you get this. And then you get the return. And if you have a debug point here and do the debugging, these things you must do if you want to really study these things. Now you can see that this is my B object. This is my B object. And first you must have foo object. Where is the foo object? Let me check where is my foo object. I am looking for the foo object first. Okay, so let's say I am in this line. Okay, let me run this. And again debug. Right, now you can see I am in this line. So that means I have the foo object. And you can see when foo object is created, inside that bar object is also created. You can see foo object, when foo object is created, as part of that process, bar object is also created because foo is associated with bar. Foo class is associated with bar class. Foo object is associated with the bar object. So likewise, you need to think. We to do some coding. Of course, this is not easy, right? Of course, if this is easy, you know what is the salary of a software engineer, right? So then everyone will become software engineers. එහෙනම් බල්ලට මේ software engineering. ඒ වෙනවා නම් අපි හරි කැමති. හැමෝටම software engineering පුළුවන් වෙනවා. නමුත් එහෙම බෑ ඉතින් හැමෝටම නේ. හැමෝටම කරන්න පුළුවන් දෙයක් නෙමෙයි නෙමෙයි. කරන්න පුළුවන් කට්ටිය අල්ල ගන්න ටක් ගන්න. potential තියෙන අය, ආසාව තියෙන අය. So you can see when foo object is created, bar object is also created because foo class is associated with bar object or bar class. You can see. One of you have sent answers. Yes, I think. Yeah. Sorry for that. Yes. Yeah, only one student has sent me the answers. Correct. Yeah. I think I replied to that one. Okay. I replied to you. Yes, I replied to that. Usually, if anyone send me answers, I reply. I reply to you, right? Yes. Sorry for that. Okay. Yes. Only one student send me answers. Only one student. Sorry for that. Okay. I forgot that. Right. So now any question about association? This is unidirectional one-to-one association. Now you must think about bidirectional one-to-one, unidirectional one-to-many, bidirectional one-to-many. Now, or you can still, if you are not 100% sure, ask ChatGPT. Right. So I want you to talk more and more with ChatGPT. More and more. හැමදාම ChatGPT එක කතා බට නම් වෙන ChatGPT එක කතා කරනකොට ටිකක් වෙලා ගියම කියනවා ආපු ෆ්‍රී එකේ ඉවරයි දැන් වෙන මොඩල් එකකට මාරු කරනවා කියලා. දැන් සල්ලි දීලා ගන්නවා තව ටික දවසක් ගියාට පස්සේ ChatGPT. So say write Java code example to demonstrate the one-to-one unidirectional association relationship. එහෙම උදව් ගන්න කිසි ප්‍රශ්නයක් නැහැ. ඔයාත් එක්ක එයා කියන දේ ඔයාලට තේරෙන්න ඕන. එයා ඔයාට ආශ්‍රය කරන්න පුළුවන් වෙනවා. එයා කියන්නේ ඔයාට තේරෙන්නේ නැති වෙන්න බෑ. Okay. See passport. So passport has passport number and nationality attributes. Okay. So then you can see getters are generated. Get nationality. So then you have person. This is very interesting example. හොඳ ලස්සන උදාහරණයක් දීලා තියෙනවා. So whenever person is created, passport is created. Every person has a passport according to this one-to-one association with passport. You can see every person is associated with one passport. Whenever person is created, a passport is created. Right? ලස්සන උදාහරණයක්. මෙතන දැන් ලස්සනට call කරලා නේද? For example, so when a person want to go abroad, maybe you need to call the passport, and maybe if it is out, say expired, you need to call the renew method. You need to check whether passport is expired or not. If not expired, you can do it. Otherwise, maybe you need to call the renew method. So likewise, so objects collaborate with each other. So then you can ask, can you give me one-to-many, right? One-to-many unidirectional association example. Then you can copy paste and run it also. Or maybe you first write the code. So then it will be array or list of objects. And this is book class. Okay. And this is author. You can see that author has list of books. Still we have not done list. Okay. Author has list of books. One-to-many. Every author has list of books. Correct, right? If you take some author, Shakespeare, so set of books. Martin Wickremesinghe, set of books. Okay. So you can see one to many association. Every author is associated with that author's book list. One to many. One to many. Or you can make it even array. If you are not yet familiar with list, this can be array of uh, array of books. Okay, rather than list of books, array of books. So then you think about bidirectional one-to-one, bidirectional many-to-many, and so on. Okay. But at least try to understand unidirectional one-to-one and unidirectional one-to-many at level one, semester one. Okay, semester one. ඉතින් ඔක ලංකාවේ ඉගෙන ගත්තත් ඇමරිකාවේ ඉගෙන ගත්තත් මොන software engineer මොන ලෝකේ ඉඳලා කෝඩ් කරත් ඔය විදිහට තමයි වැඩේ කරන්නේ. ඔය විදිහට තමයි හිතන්න ඕන. Okay. Right. So let's move forward. So I'm not going to explain you bidirectional things because if you are curious enough, try to learn those things. So maybe you can learn those things maybe while you are in semester 2, but at least in semester 1, try to understand what is unidirectional one-to-one association, unidirectional one-to-many association. That is enough semester 1 level. But if you are curious, keep looking for other concepts. No one is going to take you to the court saying that this guy has learned more than expected. Right. So I'm not going to explain you the bidirectional associations right now, but it is in the note. Maybe you can have a look at those things, right? But so that means who object can call behaviors of bar object. Bar object can call behaviors of who object. That is something like ඔයා අල්ලපු ගෙදරත් එක්ක ගනුදෙනු කරනවා අල්ලපු ගෙදරයි ඔයත් එක්ක ගනුදෙනු කරනවා. ඔයා අල්ලපු ගෙදරින් උදව් කරනවා අල්ලපු ගෙදරයි ඔයාලා ගෙදරින් උදව් කරනවා. Bidirectional. Bidirectional. So I'm not going to explain these codes. That is for if you are really interested, but otherwise you can skip the bidirectional stuff for the time being. But definitely you must understand the unidirectional association. Remember, one-to-one, I explained one-to-many, right? Book. Every author has a list of books or array of books. That is one-to-many association, unidirectional association. So this is what happens in one-to-many. When you create object of foo class and call a particular behavior do foo. Now foo class has set of bar objects. Set of bar objects. Then you can call same method or different methods of bar objects. Messaging each and every bar object or some of the bar object depending on your requirements. Now, maybe you might be wondering what are these? So you have in semester 3, you have a subject called object-oriented system analysis and design. So there you will be learning these things in more details. This is called sequence diagram. This is object diagram or communication diagram. Okay. So these are class diagrams. එතනට යන්න කලින් මේ පැල ටික හදන්න ඕන. එතනට ගියාට පස්සේ ඕක කරන්න බෑ නැත්තම්. හරි. So I just show you semester 3 note. You are semester 3 යන්නත් ඉතින් ඉන්නවනම් courses working BIT semester 3. I will show you the UCSC note. Okay. UCSC. Say class diagrams. Class diagram වල තියෙන association තමයි මේ පෙන්නන්නේ. හරි. You can see association, aggregation, composition, generalization. Generalization is inheritance. And then කතා කරේ association. මේ class එක model කරලා තියෙන්නේ washing machine කියලා. ඒක තමයි කතන්දර තේරුම් ගන්න. වෙන මොකුත් තේරුම් ගන්න ඕනේ නැහැ. හරි. One-to-one association, one-to-many association. So you must understand these things somehow. Okay. Ask questions, get it clarified, go to YouTube, use ChatGPT, do Google search, talk with friends, talk to us, ask question in the class. Okay. So it's a process that you need to follow. Right. So then you have behavioral modeling using interaction diagrams. Sequence diagrams, communication diagrams. Message passing තමයි මේ පෙන්නන්නේ අදලා හරි. So message is passed to this one, it is passed into this one. These are different objects. කොහොමද software එක develop කරන්නේ? වෙන විදියක් නැහැ. මේක කොයි වෙලාවකද තේරුම් ගන්න. පුළුවන් ආදම තේරුම් ගන්න. මේ code එක explain කරලා තියෙනවා. නැත්නම් මෙතෙන්ට ගියාට පස්සේ මේක මෙලෝ මගුලක් තේරෙන්නේ නැති වෙනවා. හරි. අයි ජීවිතේ කෝඩ් එකක් ලියන්න නැති කට්ටියට. දැන් මේ මොනවද කරන්න කියලා දන්නේ නැහැ. ඒ කියන්නේ යා ජීවිතේ Java කෝඩ් එකක් ලියලා නැහැ. ඔබ්ජෙක්ට් එකක් ක්‍රියේට් කරලා නැහැ. So learn it proper way, okay? Learn it in the proper way. Right. So that's it. I'm not going to explain you bidirectional associations, okay? And also I'm not going to explain you many how to model, because you can learn it gradually. But at least try to understand one-to-many unidirectional association, one-to-one and one-to-many unidirectional association with some practical coding, okay? Practical coding. So therefore I skip the rest of the stuff, but of course, if you are interested, you can read it. But if you are not very interested, or if you feel like it is a little bit too much challenging, okay, just skip it for the time being. Okay. Bidirectional stuff, okay. Right. So that's it about association. That's it about association. Okay. Right. So now we move on to our next topic, because we have two more concepts to understand: inheritance, polymorphism. Then object orientation is done. Okay. Inheritance, polymorphism. So any questions about association? Of course, either you may have so many questions, or you don't have enough confidence to ask questions also. That is also fine, because you just learn about association, right? But you must keep this dialogue with ChatGPT, with yourself, seriously. Seriously. Okay. Right. Now we move on to our next concept, inheritance. මේක තමයි හැමෝම දන්න දේ. හැමෝම දන්නවා ඒක seriously දන්නේ නැහැ හරි. ගොඩක් අය හිතන් ඉන්නේ object oriented programming ගම inheritance විතරයි කියලා. හරි. ඒකත් හරියට දන්නේ නැහැ. මොකද අනිත් ටික නොදන්න inheritance තේරුම් ගන්න බෑ. හරියට? Right. So what is mean by inheritance? Okay, inheritance. So then we'll look at what is overriding, calling the constructor hierarchy, abstract classes, abstract methods, final classes, final methods. Okay. Those are all related to inheritance. So inheritance means when you create a class hierarchy, of course we can create hierarchy of classes. So far we have not created any hierarchy of classes. We just create full class, bar class separately. Hierarchy means one class is a subclass of the other class. That is where inheritance happens, right? My Y class inherit features from X class, but X class cannot inherit from Z class because there's no inheritance. These are independent classes. Maybe X and Z can have association. Association we have already discussed. That is, X can pass messages to Z or call behaviors of Z object. But inheritance is something else. Actually, mostly we use association. Sometimes we use inheritance. Of course, we use both. But when you develop a software, object-oriented software, I would say 90% of the time what you use is association. Maybe 10% of the time you use inheritance. That is why I pay more attention to association. ගොඩක් අය මේක තමයි තේරුම් ගන්න නැති. 90ක් පාවිච්චි කරන එක තේරෙන්නේ නැහැ. 10 පාවිච්චි කරන එක විතර තේරුම් ගන්නවා. තේරුම් අරගෙන ඉතන මට දැන් ඔබ්ජෙක්ට් ඔරියන්ටඩ් පුළුවන් කියලා. බෑ. මේක 10යි පාවිච්චි කරන්න. Right. So inheritance means you can create hierarchy of classes. Okay. Like B class is a subclass of A class. C class is a subclass of A class. Maybe D class is a subclass of B class. That is hierarchy of classes. So what is inheritance? If someone asks what is inheritance, you must have the world's best answer. ලෝකෙදී ලස්සන උත්තරේ වගාව තියෙනවා. ඊට වැඩි හොඳ උත්තරයක් කාය ගාවත් තියෙන්න බෑ. කාය ගාවත් තියෙන්න බෑ. එච්චරයි. හරි? මේ ලෝකෙ ලස්සන මිනිස්සු ආවෙන්න try කරන්න. කාටද කියන්නේ එහෙම වෙන්න බැරිද? පුළුවන්. වැඩක් ලස්සනටම කරන්න ආවෙන්න ඕන. වෙන අය නෙමෙයි. So what is inheritance? We can create hierarchy of classes rather than isolated classes, such that classes below the hierarchy get some attributes and behaviors, so some features from classes above the hierarchy. So that feature of getting attributes and behaviors from classes above the hierarchy to the classes below the hierarchy is called inheritance. It's like you inherit from your father. You inherit certain features from your mother. Maybe your children might inherit from you and your wife. So that is also inheritance. But the inheritance in software is slightly different from inheritance of biology. Biological inheritance. There are similarities, there are dissimilarities. So therefore, don't think that inheritance in software development is 100% same as in biological inheritance. There are big differences also. At the same time, in general, the concept is the same. Okay. Right. So if someone asks what is inheritance, we can create hierarchy of classes so that classes below the hierarchy or subclasses can inherit some features from supertype, so superclasses. So that object-oriented programming languages support that feature, whether it's Java, Python, C++, C#, PHP. So they support you to create hierarchy of classes. In Java, there's a keyword called extends. I can write class A or class B extends A. So that means I have created this inheritance. My B class is a subclass of A class. Now, non-private features of A class is inherited to B class. The moment you write your code like this, B extends A, assume you have the A class. Okay. So how association relationship is decided? If A object needs the help of B object, then create a association relationship. Because a particular class may not be able to survive alone. Right? Alone. Think reality. The water පුළුවන් තනියෙන් ජීවත් වෙන්න. තනියෙන් ජීවත් වෙන්න පුළුවන් කිසිම කෙනෙක්ගේ සහායක් නැතුව. එහෙනම් වට මෙලෝ ඇසෝසියේෂන් එකක් ඕනේ නැහැ. ඔයාගේ වැඩ ටික ඔයා තනියෙන් කරගන්නවා. හැබැයි එහෙම බෑ නේද? So your question is how do you decide whether a particular class needs the association of whether that class need to have association relation with this other class. මම පොඩි උදාහරණයක් කියන්න. මේ ඔයා. හරි? say nip person. හරි? අපි හිතමු ඔයා ඇවිල්ලා මිනිස්සෙක්. ඔයාට තනියෙන් පාන් පුච්ච ගන්න බෑනේ. පුළුවන් නම් කමක් නැහැ. සාමාන්‍යයෙන් තනියෙන් පාන් පුච්චන්නයි ඔක්කොම කර කර ඉන්න බෑනේ. එතකොට ඔයාට පාන් ගන්න ඕන වෙනවානේ. ඒ පාන් ගන්න ඕන නම් ඔයාට බේකර් කියන ක්ලාස් එකත් එක්ක ඇසෝසියේෂන් එකක් හදන්න ඕනේ. නැත්නම් බේකර් නැත්නම් වෙන්ඩර්. ඔයා කෙලින්ම සමහරට බේකර්ගෙන් නෙමෙයි ගන්නෙ. ඔයා කියන කඩේට ගිහලා බඩු අරන් ගෙනන්නේ නේද? කඩේට ගිහලා බඩුව අරන් එනකොට ආ කියන්න බෑ මුදලාලි මට මෙන්න මේක දෙන්න නැත්නම් අරන් ගිහලා සුපර් මාකට් එකේ කවුන්ටර් එකට දෙනවා. that is association. يعني ඔය ඇසෝසියේට් වෙනවා සුපර් මාකට් එකක්. ඒක නෝ සුපර් මාකට් එකත් එක්ක ගන්න දෙනකොට. ඔය බැංකුවත් එක්ක ඇසෝසියේෂන් එකක් තියෙනවා. බැංකුවට ගිහලා සල්ලි ගන්නවා, බැංකුවෙන් සල්ලි දානවා. Association. Now say I am a teacher, lecturer. So you are a student. There's association between lecturer and student. Right? So lecturer can facilitate lectures to the student. Association. හැබැයි අපි ඉද මෙතන ඉන්න පාතාලකාරී දේශපාලකෙක්. මම සාමාන්‍ය දේශපාලකයන්ගෙන් ඇසෝසියේට් කරන්නේ නැහැ. දැන් මටත් ඕන නම් උන්ගේ පස්සේ කියලා රොස්සාවක් හොයාගන්න. ඒකට මට ඇසෝසියේෂන් එකක් හදාගන්න දේශපාලකයෙක් එක්ක. ඔන්න ඒ පාර කැන්වසින් යන්න ඕන. දැන් ගෙවල් වල ඉන්න අම්මලා තාත්තලා කියලා ඇසෝසියේෂන් හදාගන්න ඕනේ දේශපාලකයෙක් එක්ක මේ දවස්වල. ඇයි ඒ? ගෙදර ඉන්න පිංගුත්තරයෙක්. මුට තනිය රස්සාවක් හොයාගන්න බෑ. පිංගුත්තරයෙක් හරි පිංගුත්තරියක් හරි ගුත්තරියක් හරි. මේකේ රස්සාවක් හොයාගන්න බෑ. දැන් මුට මොනවා ඉගෙන ගත්තත් මුට ඉන්ටර්විව් යන්න තරම් පෞෂයක් නැහැ. ඒතර අම්මලා තාත්තලා මොකද කරන්නේ? පලාතින දේශපාලකයෙක් එක්ක ඇසෝසියේෂන් එකක් හදාගන්න. ඇයි ඒ? මේක ගිහිලා කියන්නේ අපේ ගෙදර ඉන්න පිංගුත්තරේ මුට රස්සාවක් කරලා දෙන්න. අන්න ඇසෝසියේෂන් එකක් හදාගන්න විදිය. හැබැයි එහෙම පිංගුත්තරයෙක් ගෙදර නැත්නම් අම්මට තාත්තට ගිහිලා දේශපාලකයෙක් එක්ක ඇසෝසියේෂන් හදාගන්න ඕනේ නැහැ. එයා බොහොම නිදහසේ ජීවත් වෙනවා. I hope you got the answer. Okay. So if you need the help of this object of this class need the help of this object of this class, make association. මොකද නැත්නම් instance variable එක හදන්න බෑ. එහෙම ඕනේ නැත්නම් එපා. Okay. එහෙම ඕනේ නැත්නම් එපා. So then think about more practical things like should my account class, should my order class associated with payment class? Maybe payment class need the association with email utility. Maybe every time you do a payment, you need to send an email. So then payment class must be associated with email class. So that the pay method you can call the send email method of the email utility class. Likewise, right? So likewise, that is how the association is decided. It's a very good question actually, right? කොහොමද මම තීරණය කරන්න කියන එක නේද? ඒක තීරණය කරන්න විදියක් තියෙන්න බෑ. ඔයාලට එයාගේ උදව්වක් ඕන නම් associate relationship එකක් තියෙනවා. උදව්වක් ඕන නැත්නම් එයා නැතුව ජීවත් වෙන්න පුළුවන් නම් නැත්නම් ඔයාගේ object එකට එයාගේ උදව්වක් ඕන නැත්නම් ඒ class එකේ objects වලින් you don't need association. Simple as that. That is with practice, your experience, you will decide whether you need association relationship or not. ඒක සාමාන්‍ය ඉතාලම සරල තීරණයක් බවට පත් වෙනවා. දැන් අපිට මහා ලොකු තීරණ ડોක්ටර් කෙනෙක්ට මහා ලොකු තීරණ නෙමෙයි නේද? එයා දැක්කා ලෙඩා දැක්කම කියන මෙන්න මේක දෙන්න කියලා. සමහර මෙන්න මේ පෙත්තක් ගාලා මට දෙන්න කියලා. එයාට එක්ස්පීරියන්ස් එක තියෙනවා. එයා ඒක දැන් සබ්ජෙක්ට් එක ඉගෙනගෙන තියෙනවා. ඒ වගේ ඔයාටත් ඒක එහෙම වෙනවා. ටිකක් කල යනකොට. හරි? ඔයාලට පේන මේ දේවල් ඇසෝසියේට් වෙන්න ඕනේ, මේ දේවල් ඇසෝසියේට් වෙන්න ඕනේ. Right. Right. So let's get back to the inheritance. Okay. So inheritance, this is more biological example because that is something you are already familiar. Okay. But you can see this is different from biology also. So inheritance in software development is generalization, specialization. Not you inherit from father, blah blah blah. ඒ inheritance එකක් නෙමෙයි අපි මෙතන කතා කරන්නේ. ඒක මම කිව්වේ ඒක නෙමෙයි මෙතන තියෙන්නේ කියලා. හරි? So in software development, in object oriented programming, inheritance means this is more general class, this is a special class. So your special class has features from general class plus some special features. That is what inheritance in software development is. So therefore in a way this is different. Because in reality, what we see is object inheritance. අපි biologically පේන object inheritance එක. class inheritance එක නෙමෙයි. තාත්තගෙන් පුතාට දුවට එයාගෙන් ඊළඟ මුණුපුරාට ඒක object inheritance. But this is class inheritance. Okay. Something like mammals are animals. ශීරපායු කියන්නේ සත්ත්වය. Birds are also animals. Then parrot is a special case of a bird. Pigeon is a special case of a bird. මේ බර්ඩ් ගේ පුතෙක් පිජන් නෙමෙයි යා. ඒකයි මම මේක වෙනස් කියලා. මේ මැමාගේ පුතා ලයන් නෙමෙයි යා. Lion is a special case of a mammal. So this is object oriented inheritance. Okay. Special general case, special case. And these are even special case of this general case. This is a special case of this general case. So when you go up, you are getting more and more general cases. When you go down, you make it more and more special. Then dog get the it was another special case. Maybe Alsatian, Rottweiler, special case of a dog. Okay. So when you go up, it's more and more general concepts. When you go down, you are into more and more specialization. More and more specialization. Right. So the next question is, now we are talking about, now you know that biological inheritance, it's object inheritance, right? ඒක ඇවිල්ලා මේ පරම්පරාවක් පවත්වා ගැනීමක් එතන වෙන්නේ. එතන මේ specialization generalization කතාවක් නැහැ. එනවා. පුතා කියන්නේ තාත්තගේ special case එකක් නෙමෙයි. එතන මොනවද inherit වෙන්නේ? Maybe skin color, some behaviors, how maybe how your mother smiles, you also smiles like that, inherited. Maybe your mother's skin color, you also get it. නේද? සමහර අම්මගේ මූණේ උපන් ලපයක් තියෙනවා, සමහරට ඔයාලට උපන් ලපයක් එන්න පුළුවන්. මම දන්නේ උපන් ලප ඉන්ජෙක්ට් කරනවාද කියලා මම දන්නේ, මම බයොලොජි කරලා නැහැ. Maybe something like that. අම්මගේ මූණ වල ගෑනවා නම් සමහරට දුවගේ මූණ වල ගෑනවා. That is what biological inheritance is. But this is not biological inheritance. So this is features are inherited. For example, say account class. So you have the current account class, savings account class, special cases of account class. This is general case, these are special case. So then special case of savings account is super savings account. So what are inherited? So the simple answer is non-private attributes and behaviors are inherited. Perfect answer. What are inherited to a subclass from the superclass? Non-private attributes and behaviors. Private දේවල් inherit වෙන්නේ නැත. පුද්ගලික දේවල් inherit වෙන්නේ නැහැ subclass එකට. Okay. Non-private attributes and non-private behaviors. If you have marked a particular attribute private, a particular behavior as private, those are not inherited to subclass. So that means when you create object of this class, private attributes and private behaviors are not available to this object. But there are non-private attributes and behaviors. Those are also available in addition to the attributes and behaviors defined in your this class, special class. Okay. Right. So then someone must ask, why do you want to create hierarchy of classes? ඇයි අපිට මේ classes hierarchy එකක් වගේ හදන්නේ? So simple answer is code reusability. Because your subclass inherit non-private attributes and behaviors from supertype. So therefore you don't need to recode that. Because your subclass has all the non-private attributes and behaviors plus any special attributes and behaviors. Okay, any special attributes and behaviors. So your coding is more reusable now. Coding in your supertypes are reusable in subtypes. Because we don't want to do the same thing over and over. And we want to cut down our software development effort. We want to do things faster. Okay. I told you that object-oriented software development is more reusable, maintainable, but upfront there's overhead. Part of that overhead is understanding these concepts. What is abstraction? What is encapsulation? What is association? What is inheritance? But it will pay off when you develop complicated software. When you develop software that you want to maintain for next 10 years. And also inheritance of class hierarchies facilitate the next object-oriented concept, that is polymorphism. So without inheritance hierarchy, you can't use the concept of polymorphism. Still, we have not discussed that. Okay. So the polymorphism is the hardest concept to understand in object-oriented programming. ඕක තමයි අමාරුම concept එක තේරුම් ගන්න. තාම අපි ඒකට ආවේ නැහැ. හැබැයි ඒකට ඒක කරන්න අපිට අවශ්‍ය ෆවුන්ඩේෂන් එකක් හදලා දෙනවා inheritance hierarchy එකක් හදුවම. But inheritance and polymorphisms are two different things, but polymorphism depends on inheritance. So those two concepts are interrelated. It's polymorphism depends on inheritance, not inheritance depends on polymorphism. Okay. Right. We'll discuss polymorphism later. Okay. Definitely not today. Right. So let's do an example, code example. Okay. Code example. Is that only one superclass? Yes. In Java, yes. Because Java supports only single inheritance. Class can have only one superclass, not more than one. In Java, Python, C#. C# actually support bit of multiple inheritance. PHP, Java, Python, PHP, single inheritance. But languages like C++ supported multiple inheritance. A class can inherit from multiple classes. Your class C can inherit from both A and B, but that is not supported in modern programming languages like Java, Python. Modern programming languages only class can have only one supertype, but supertype can have many subclasses. This is not multiple inheritance. This is multiple inheritance. So this is not allowed in modern languages. So there's a reason for that, because when you allow multiple inheritance, it creates unnecessary complication called deadly diamond death phenomena. So because of that, actually C++ supported it and still it supports, but people very rarely use that feature because it results in some unnecessary complications. Okay. Unnecessary complications. Right. What are those complications? If you are interested, do a Google search, go to YouTube and search, ask on ChatGPT, ask ChatGPT to explain the negative consequences of multiple inheritance and so on. But that, of course, you can do, you will understand those after you first understand these basic concepts. දැන් මම එක තේරෙන්නේ නැකන් නෑ. දැන් මහන්න එපා multiple inheritance කරන්න බැරියයි කියලා. තාම තේරෙන්නේ නැකන් නෑ. හැබැයි තව මාසයක් දෙකක් ගියාට පස්සේ මේ ටික අල්ලගත්තට පස්සේ සමහරට ඔයාලට තේරෙයි ඇයි multiple inheritance support කරන්නේ නැත්තේ කියලා. Okay. So let's do sort of a practical coding, okay, about inheritance. Right. For example, I have a class called animal. ගොඩක් අපි classical example, classic example. Animal. So then let's say I have a class called, say, dog. And let's say my animal class has some attributes, say string, name. So every animal has a name. අපි මේක සුවයක් හරි මොකක් හරි කියලා. I'm just building a story. Animal class has name. So that means every animal object has name. I just make it non-private. That means it is not well encapsulated or data hidden, but I just want to explain that attributes can also inherit it, right? So that is why I just make it non-private. So maybe every animal has a behavior. I just introduce one attribute, one behavior, just to make it simple, okay? You can have any number of attributes and behaviors. Let's say every animal has a behavior called maybe eat. Okay. සතු සාමාන්‍ය කනවන්නේ. Say void, eat. Let's have S out there saying animal eat. Right. So both are non-private. So therefore, if you have a subclass of animal, that class is also having name and name attribute and need behavior. So dog, I want to make dog is animal. That is dog extends animal. Right? Dog extends animal. Okay. Now my dog class, I have not added anything, but my dog has a name. My dog objects have eat behavior. Why? Inherited. Inherited. Right. So let's create a test class. So let's call this animal test or inheritance test. Main method. Say I create dog object, not animal object. Say D1 equal new dog. And you can see that already I can set name. Of course, my dog class has no code, but dog is animal. Okay, so let's call it doggy. And not only that, I can call eat behavior because dog is animal. And I can run it. Of course, the animal nature is being called. Animal eats because dog is animal. So now my dog shows animal behavior of eats because I have not written any special behavior for eat in my dog class. Because dog is animal. බල්ලා කන්නේ සාමාන්‍යයෙන් පූත කන විදිහටම තමයි නේද ගොඩක් අය. ලොකු වෙනසක් නැහැ. නේද? බල්ලා කන්නේ බූරුව කන්නේ කන ಜಾති විතරයි වෙනස්. Right. So therefore your subclass inherits non-private attributes and behaviors. Okay, so let's add one more method for my animal class. Let's say we have another method. Say speak. I'll say animal speaks. I'm just building a story. මොකද stories වලින් තමයි අපිට concept ඉගෙන ගන්න පුළුවන්. හරි අපි සරල කතන්දර වලින් තමයි ඉගෙන ගන්න ඕනේ. ඊට පස්සේ ආ පාවිච්චි කරන serious දේවල් වලට accounts වලට inventory management වලට ඕන දෙයකට. හැබැයි subject තේරුම් ගන්න ඕනේ ඉතාම සරල කතන්දර වලින්. Okay. Right. So now of course my output I can call the speak behavior also. Dog. But my dog still speak like animal because I have no code that told in my animal class. It says animal speak, but actually it is my dog object because my dog is animal. My dog is animal. Why? Dog extends animal. Right. So therefore, when your class extends from another class, you inherit non-private attributes and behaviors. So at the same time, you can add your own attributes and behaviors. For example, my dog class can have its own attributes and behaviors. Let's say it has a breed, string, breed. Maybe dog has its own behavior. Say void, roam. බල්ලෝ යනවනේ පොඩ්ඩක් දදා රවුම් ගහන්න යනවනේ roam කියු. Roam. Okay. So now it is in the dog class. Dog class. So let's say S out, dog roams. අපිට ඕන මෙයාගේ නමටත් prefer කරන්න පුළුවන්. We remember animal has a name. අපිට ඕන නමත් prefer කරමු. Say name plus animal leads. මොන animal lead කියලා තමයි බලන්න object එකට නමක් set කරොත් එහෙම. Name animal speaks. Here we'll say name එක කියලා තමයි කියන්නේ. ඒකට බලන්න මොන object එකද කියලා. Here let's give our dog a name. Okay, we have given a dog name. Now my dog not only can eat and speak like animal, my dog can roam like a dog. Roam කරන්නේ ආ බල්ලෙක් වගේ. කන්නේ සතෙක් වගේ. කෑ ගහන්නේ සතෙක් වගේ. හැබැයි මු roam කරන්නේ නම් බල්ලෙක් වගේ. Because roam is a dog behavior, not animal behavior. Let's try it and see. Can see? Okay, අපි ඔන්න space දාලා නැහැ. So it's the same object, right? Same doggy object, but doggy eats like animal because I have not add any special features for eats in dog class. Dog speaks like animal, but dog roams like a dog because that behavior is in the dog class. Dog class. Right? So that now you can see we can do two things. You inherit non-private attributes and behaviors, subclass. And subclass can have its own attributes and behaviors. For example, now I can set breed for the dog. Dog to breed that then the dog class has that attribute. Okay. So let's say my dogs D1s breed this. So something I don't know. I don't know the spelling. Rottweiler, whatever. I don't know the exact spelling. Okay. So you can see these are dog specific attributes. These are dog specific behavior. So there are three things you can do in the subclass. You inherit non-private attributes and behaviors. You can add new attributes and behaviors, and you can override behaviors. That is the third thing you can do. තුන්වෙනි දේ තමයි subclass එකට කරන්න පුළුවන්. If you are not happy with the inherited behavior, you can override it. You can override it. So let's say I am not happy with the speak behavior of animal for the dog because dogs speak in a different way. So therefore I can override this behavior. මට ඕන මෙයා override කරන්න පුළුවන් dog class එකේ. How? Make sure you write the same method signature, but write your own implementation. I will say dog speaks. Oh, okay. So let's say bow. Now, if you call the speak behavior, it is the dog method that is called, not the animal method, because it checks from the from lower to the upper. If there's a speak method in dog class, that is used. If there's no speak method in dog class only, animal class speak method is called. So in this case we have, right? But if you take something like eat, there is no eat behavior in dog class, so therefore animal behavior is called. That is how inheritance works. යට එකේ නැත්තම් තමයි උඩ එකේ තියෙන එක ගන්න. ඕවර්රයිඩ් කරලා දෙනොත් ඒක තමයි ඕවර්රයිඩ් කරපු version එක තමයි use කරන්නේ. ඒතර උඩ එක කෝල් කරන්නේ නැහැ. ඒ කියන්නේ ඔයාට ඔයාගේ අම්මගේ මොනාරි ඉන්හෙරිට් වෙනවා. හැබැයි ඔයාට කැමති නම් ඒ විදිහට ඉන්නත් පුළුවන් නැත්නම් වෙන විදිහකට ඉන්නත් පුළුවන්. නේද? ඔයාට ඔයාගේ අම්මගෙන් ඉන්හෙරිට් වුණා hina වෙන විදියක්. හැබැයි ඔයා හිතලා ඒ විදිහට hina වෙන්නේ නැහැ, වෙන විදිහට hina වෙනවා. That is called overriding. Overriding. So now you will see that speak behavior of the dog is not the animal speak anymore. It is a dog speak because we have override it. Now it is dog speak. Earlier it was dog animal speak because we have overridden the speak behavior. So those are three things you must understand in inheritance. Your subclass inherit non-private attributes and behaviors. Your subclass can add new attributes and behaviors. Your subclass can override behaviors. Nothing else. ඔන්න ඔය තුල තමයි කරන්නේ subclass එක. වෙන මොකුත් කරන්න යන්නේ නැහැ. Okay. Yes, you can use whatever. Java is Java. Java is Java, right? Whether you use Visual Studio Code or IntelliJ or whatever. Because you don't depend on the ID. IDs are just to show these highlighting colors, showing error message. That's it. It has nothing to do with running your Java class. Okay. Right. So any questions? So we are pretty much done with the basics of inheritance. What we get, what we can do. Non-private attributes and behaviors are inherited. You can override inherited behaviors and you can add attributes and behaviors, your own attributes and behaviors. So overriding means you write the same method with the same signature, but you write your own implementation. So then for subtypes, the subtypes behavior is called, not the supertype. Okay. This is overriding. I already explained overriding. Right. Dog speak behavior I override so that it is not animal behavior we use the dog behavior. Okay. Right. Any questions? Any questions about up to this point? Can superclass call subclass? There's nothing called superclass call subclass. Uh, okay. So the question is wrong actually. Actually, the simple answer is there's nothing called superclass called subclass. Because inheritance is something your language control, but not something you control. Okay. So inheritance means which methods are available to you, not subclass called superclass or superclass called subclass. Okay. But when it comes to constructors, there's a concept like that. Maybe your question is, can superclass call behaviors of the subclass? Maybe there's a method called X in superclass, there's a method called Y in subclass. Maybe your question is, can my X method call Y method? So for that, the answer is no. No. But your Y method can call X method. Because every dog is animal. So therefore, safely, your dog can call animal behaviors. But not every animal is a dog. So therefore, your animal behaviors can't call dog behaviors or cat behaviors. Because not every animal is a dog or cat. But every dog is animal. So therefore, Y method can call X behaviors. But X method can't call Y behaviors or the subtype behaviors. Uh, maybe that is your question. No, I don't know. Okay. Right. Right. So abstract class and abstract method is a very simple concept. If you mark a class as abstract, you are not supposed to create objects of that class. Simple as that. For example, uh, now if I want, I can create an animal object. Okay. If I want, I can create animal object. There's no restriction, right? For example, I can say animal, say A1 equal new animal. Okay. But maybe this is not practical. For example, if you go to a bank, you may create savings account, current account, super savings account, and so on, senior citizens account. But there's nothing called you can go and create account. So when you ask for create account, they will say, what kind of account? You can't create accounts. You can't open account. You can open current account. You can open savings account, right? Because account is too abstract, too abstract. In reality, there's nothing called account. So similarly, animal is abstract. So in reality, what you see is dog, cats, parrots, not animals, right? So in that case, maybe you want to restrict object creation of some of the super types. Now I can create animal objects. and even I can call eat behavior, set a name. Okay. Okay. Say any. Even I can call behaviors which are in animal class like eat, but maybe this is not correct. So in that case, what I can do is I can mark this class as abstract class. Now the moment you call mark it as abstract class, now you can't create objects of that class. Still you can create dog classes, dog objects, but not the animal objects, because animal is an abstract class. Okay, animal is abstract class. Okay. So that is the concept of abstract class. So if you mark a class as abstract, you can't create objects out of that. So now I need to come in this. Right. So the next concept is abstract method. Abstract method means you want to have the method here, but you don't want to implement that method. Right? For example, say eat behavior. You don't want to implement this eat behavior in the animal class, but you want it. I will tell you why, because polymorphism, which we will be discussing in the next class. To support polymorphism, you want to define your eat behavior, but you don't want to implement that behavior. So in that case, you can mark your eat, say, or whatever the method as a abstract method. Abstract method. So that is abstract method. So that means you have a method, but you have not implemented in the animal class. Okay. Or maybe I will mark my speak behavior as abstract behavior. Okay. Or, okay. Let's keep the eat behavior as a normal behavior. Maybe speak behavior. Let's make it abstract behavior. Okay. Abstract behavior. Now you can see that it's abstract method. So if you have abstract method, your superclasses must override it. Now earlier we just override it because we need a different feature, but now it's a must. Now if I comment this, I get an error here. Because if you have any abstract method in supertype, if you override that class, you must override that method. Okay, you must override the abstract method, otherwise you will get error. Okay, so that is what abstract class and abstract method is. So other rule is if you have at least one abstract method, you must mark your class as abstract. It's a must. Otherwise, it's optional. But if you have at least one abstract method, you have no other option. Mark your class also as abstract. Now you will see I have abstract method. Class is not abstract, therefore I get error. Right? Abstract method in a non-abstract class. So if you have at least one abstract method, make sure your class is also abstract. That means you can't create object out of that. Okay. Right. Any questions? So it's again, if someone asks why do you need abstract classes? Because there are some two general classes where we are not supposed to create objects. Okay. We are not supposed to create object. Like bank account, animal. Right. So our final concept is final class and final method. Okay, final class and final method. Okay. If you want your method, or if you don't want your method to be overwritten, you can mark that method as a final method. Right? For example, I will use a different class. I will call this A class. And let's say I have a method called void X method. Say sum is out X. Now assume that I don't want my subclass of A class to override this. Say, let's create a subclass of A class. Let's call it B class. And B extends A. Now when B extends A, I have the right to override X because that is supported feature. Let's say X in B. This is X in A. But if you want to prevent that, if you want to prevent subclasses overriding a particular method, now I can. If you want to prevent that, mark this as final method. If a method is final, that means you say that you are not supposed to, or subclasses must not override this method. Now, if you go to the B class, there's error, right? What is error? X cannot override or X cannot override because it's a final method. Final method. You can't override final method. So if you don't want a particular method to be overridden, mark it as final. Mark it as final. And if you don't want a class to be subclass, something like this, then mark your class as final. So then you don't need to mark your method final now because your class is final now. Now you can't even subclass. Okay. For example, now we say cannot inherit from final A because it's a final class. So if a class is final, you can't subclass. If a class is not final, but the method is final, then you can subclass, but you can't override that method. Right. So I hope you got it. And so then what is the purpose of final class? You can create objects, but you can't inherit. What is the purpose of abstract class? You can't create object, but you can use it for inheritance. Now we have another rule that is class cannot be both final and abstract. Right? You can't mark the class as both final and abstract. Why? Final class you can't, or subclass, abstract class you can't create objects. So if you can't create objects and if you can't override inherit, right? It's a useless class. It's a useless class. Okay, so that is why a class cannot be both abstract and final. Okay, right. So that's it about inheritance. Okay, simple inheritance. Okay, so we discussed what is abstract class, what is abstract method. Abstract methods you must override in subtypes. If it is abstract class, you can't create objects out of that. And if you have at least one abstract method, you must mark it as abstract class as well. Okay. And final class and final method I explained. Final method you can't override. Final class you can't subclass. Okay. So this is a useless combination. A class cannot be both abstract and final because it's a useless class. Because abstract you can't create object, because final you can't subclass. Right. So we discussed these things, right? So we did this demo last time. Right. So now we have finished. What are the object-oriented concepts we have discussed? Of course, what is object, what is class, attributes, behaviors, how those are mapping to instance variables, class variables, instance methods, and class methods. Then we discuss what is abstraction, encapsulation, data hiding, Java bean, which is a very special case only. And also we discuss what is association and message passing. Inheritance also we discuss, including what is abstract class, abstract method, final class, final method, what is overriding. So now we have only one more concept to study, learn, that is polymorphism, that we will do next class. So then object orientation is over. Of course, there's another small topic that is inner classes. Okay, that is a very advanced concept. Of course, it is also part of the object oriented, but it's very rarely used concept. Okay, so then object orientation is over. Once object orientation is over, 2/3 of your syllabus is over. So then we have some specific topics which are not directly related to object oriented programming or structured programming. Those are general concepts that we will use, like database connectivity, UI development, collections, exception handling, and so on. Your syllabus is huge because you don't have programming in any other semester. So when we say you don't have programming in any other semester, it doesn't mean that you don't have programming topics. Like, of course, you have web development, enterprise application development, right? And so on, mobile development. But you don't learn programming as programming subject anymore. That is why your syllabus is huge. Okay. Right. So any other question?